The basic principle of projectile motion is that motion in the x-axis, y-axis, and z-axis are entirely independent of each other. For the purposes of this video, we'll only be talking about the x and the y-axis, but keep in note this also applies if you add another dimension. So what does it mean that motion in the x and y-axis are independent of each other? Obviously, we don't just have baseballs traveling in a straight line without ever changing direction. It's going to fall over time. You could have something that's going like this. But what the main principle of projectile motion states is that all of these can be broken up into motion in each axis. Let's take a look at this line, for example. It's going some amount up and to the right. This can be broken up into motion in both the x and the y-axis. So it's moved to the right however many units, and it's moved up however many units. Simple enough. Now, what do you think would happen if something is falling? Suppose I have two baseballs. One of them I drop straight down, and the other one I throw off to the side and it falls. Which one do you think is going to hit the ground first? Now, your normal instinct might say that this baseball is going to hit the ground first, because it has a shorter distance to travel. However, both of these baseballs will hit the ground at the exact same time because gravity only operates in the y-axis. And so both of these balls move the exact same distance in the y-axis. It's just that this one moves over in the x-axis as well. Therefore, it must have an additional force being applied to the right. This also works if you don't have a graph at all. Say I have an object moving in this direction. This can be broken up in any number of ways. You don't just have to look at how far it moves this way and how far it moves this way. You could also look at how far it moves this way and this way. This is the exact same principle as polarization of light. Light is a combination of an electric field and a magnetic field oscillating 90 degrees of each other. So if you were to look at this from the side, it would look like this at one point and like this at another. In unpolarized light, you have light like this layered on top of each other, moving in all different directions. However, whenever you polarize light, what happens is that you have chains of molecules lined up in sequence. Say you have an electric field that passes into one of these molecules at this angle. How do you suppose it fits through this chain of molecules? The electric field is a force that can cause a molecule to move to the left or to the right, depending on which way it hits the molecule. If the electric field hits one of the molecules in this chain of molecules at this angle, well, it can only work with the energy that's being transmitted that way. So that energy is absorbed, and this molecule moves a little bit that way, but this energy is allowed to pass through. And so on this example, it would look like this. This much energy is absorbed, and this much is allowed to pass through. Now, given all of the different directions that light is passing through this polarization lens, statistically, 50% is going to make it through, which is why whenever we pass light through a polarization lens, there's about a 50% reduction in energy.